All right, so this is the key to the equations, the worksheet 6, and there are two problems on solving linear equations, so let's go ahead and look at that. So number one, you had negative 3 times 2x plus 3 plus 2 times x minus 5, and that's going to equal 6x minus, and then in parentheses you have x plus 4. All right, so we're going to solve this linear equation. Now, one of the things that makes this a linear equation, which students can see right away, is that the exponent of the variable, of each of those variables, is 1. So x to the first, x to the first, x to the first, x to the first. So each of those exponents have the x are 1. And there are no in the denominator. So if you notice, well, you might say, well, there's no denominator there. Well, if you imagine that there is one, it'll be all of this divided by 1, this divided by 1, this divided by 1 is 1. But the point is that the denominators do not contain any variables. All right, so you have this linear equation. Now, when solving any equation, sometimes you may want to go ahead and see if the first step may be to use the distributive property to get rid of those parentheses, because I have some parentheses here, parentheses here, parentheses here, and a set of parentheses here. And if you notice, when I read this as negative 3 times, and then in parentheses, all of this is 2x plus 3. So we have this binomial here, these two terms that are being multiplied by negative 3. And so that's where the distributive property comes in. So what some students like to do is they like to show this to imply that they're going to multiply each of those two terms by negative 3. And the same thing here, they're going to multiply x and a negative 5 by a positive 2. Now when you get to this point, you need to be a little bit careful, because technically, if you think about this, and let me go ahead and write this on here. So when you think about this, you can think about 6x minus x plus 4 in several ways. You can think about it as 6x minus 1 times x plus 4, because notice the coefficient that's in front of this expression is negative 3. The coefficient in front of this expression is positive 2. And the coefficient in front of the expression x plus 4 is really, if you want to change this in addition problem, is really negative 1, because you can also think of this as 6x. Remember, subtraction is the opposite of addition, so you would say add, and then the opposite of 1 is a negative 1, and then x plus 4. And then you would distribute a negative 1. And you could have done that here as well. This also means that 6x subtract x plus 4 means the same thing as 6x plus the opposite of all of those terms. All right, and so when you see what's going to happen here is that the opposite of x is a negative x, the opposite of positive 4 is a negative 4. And you're going to see that right here. All right, so let's go ahead and in this case, we're going to think of this as either taking the opposite of each of those terms or multiplying each of those terms by negative 1. All right, so negative 3 times 2x is a negative 6x using the distributive property. Negative 3 times a positive 3 is a negative 9. A positive 2 times x is a positive 2x. A positive 2 times a negative 5 is a negative 10. So look how I wrote this. Equal 6x, and then let's go ahead and get rid of this set of parentheses. So the opposite of x, or x times a negative 1, is a negative x. And the opposite of 4, or 4 times a negative 1, is a negative 4. So a first step was to use the distributive property to get rid of those parentheses. And then we have all these terms here. We have this term, this term, this term, this term, and so on. So we have 4 terms on this side and 3 terms on this side. And so what you want to do now is to combine like terms. So when I combine like terms, a negative 6x and a positive 2x is a negative 4x. A negative 9 and a negative 10 is a negative 19. Equal, this equal sign, and then 6x minus x, those are like terms, so that's 5x, and I get 5x minus 4. All right, at this point, what you want to do, since this is a linear equation, is you want to bring all the variables to one side, all the constants to the other. Because remember, the idea when solving any equation is that your last step, you want something to be like this: x equals some solution, right? Some number. So that's what you want your last step to be. So you can get all of this to be this: x equal, when you're solving an equation, x equal some number. All right, or whatever that expression could be. All right, so we're going to we're going to bring the, and it doesn't matter which side you bring the variables on or the constants on. It does not matter. So I'm just going to go ahead and bring the variables to the left-hand side. So this is a positive 5x. So remember, what you do to one side, you do to the other. You're going to use the properties of equality here. So if I add 5x to both sides, that's going to help me. It's mathematically a correct statement, but it's not going to help because 5x plus 5x, I still have the variable x on both sides. So think the opposite. So if this is positive, what you want to do is subtract 5x, because 5x minus 5x is 0. But what you do to one side, you have to do the other. And I'm going to go ahead and align my like terms to make things easier on me. And then the next step is to take what I just wrote here, and then I want to combine like terms. So a negative 4x and a negative 5x is a negative 9x. Then I'm going to bring down the minus 19 equal, this is 0, and 0 minus 4 is a negative 4. And then a couple more steps. Remember, I'm trying to get the variable x by itself, so I need to get rid of this constant. So right now I'm subtracting 19. The opposite is to add 19, because that's the only way I can get this term from the other side, or from this side. Combining like terms, so notice I align my like terms, so I align my constants with each other. So then I'm going to combine like terms. A negative 19 plus 19 is 0, so I get negative 9x is equal to a negative 4 and 19 is, what's that, 15? And then the next step, so remember, I'm trying to get x by itself. So remember this idea here. Your last step wants to be, or needs to be, x equal whatever your solution is. So right now, and I'm going to go ahead and rewrite this over. So I have 9x equal 15. So right now, multiplying x by negative 9, the opposite of multiplying by negative 9 is to divide by negative 9. So I'm going to divide both sides by that coefficient. So make sure you're dividing by negative 9. Dividing by 9 is not going to help, because this is still not x. This would be a negative x. Now, you can do that. Then you would have to do another step where you would divide both sides by negative 1. All right, so you just got to be a little bit careful. So dividing both sides by negative 9, I get negative 9 divided by negative 9 is 1. 1 times x is x, equal. And then we have negative 15 ninths. And then when I reduce that, because both of these numbers, both of these integers are divided by 3. So negative 15 divided by 3 is going to be a negative 5. And then 9 divided by 3 is going to be 3. So we get, I'm going to go ahead and write this here. So we get x equal negative 5/3. Now if I want to write this as a mixed number, because this is an improper fraction, I can do that. So remember, you're going to say, and I'm going to go ahead and do that here. So you're going to say 3 divided into 5 is 1 time. 1 times 3 is 3. Subtract, you get 2. So 5/3 would be 1 and 2/3. But it's a negative, so you're going to say negative, or you're going to say negative 1 and 2/3. All right, so there's your solution. All right, so that is number 1. All right, so let's look at number 2. So number 2, we had, this is still a linear equation, and because you notice that the variables in the numerator, this time you have a denominator other than 1, but there are no variables in the denominator, but you still have x to the first, x to the first, x to the first, so this is still linear. And so let's look at that one. So this will be number 2. So number 2, we have, all right, we have this problem. We have 3x minus 4 divided by 2 minus x plus 4 divided by 6 equal 5x divided by 4. All right. And so what you want to do is first is to make things easier, the most efficient way here is to go ahead and clear the denominators. So you want this to be a 1, this to be a factor 1, this to be a factor 1. To do that, you have to find the least common denominator. So your LCD. So what is the smallest number that 2, 6, and 4 will go into? So the smallest number that 2, 6, and 4 will go into evenly is 12. Now, someone said that they're going to multiply both sides by 24, let's say. Well, that's fine. You can use 24. It's just not the least. So when you use numbers that are, when you multiply both sides by a number that is not the least, it becomes a little bit more challenging because the numbers, the terms, the coefficients of those terms become larger. All right, so always use the least. It makes things a lot easier for you. So the smallest number that 2, 6, and 4 go into is 12 because 2 goes into 12 6 times, 6 goes into 12 2 times, 4 goes into 12 3 times. Okay? All right, so you want to your LCD needs to be a number that all these are divisible into. So what's the next step I'm going to do now? I'm just going to go ahead and rewrite this over. And so what you want to now do to clear those fractions is you want to multiply both sides by the least common denominator. Now notice that on this side I see two fractions. So I'm going to put those two fractions in brackets or parentheses. And on this side, I only see one fraction, so I'm going to leave that alone. I'm not going to put in parentheses or brackets because then it'll make it a little bit too confusing. So then you're going to say you can multiply this side by 12. And remember, what you do one side, you do the other. Properties of equality. So if I multiply the left side by 12, I'm going to have to multiply the right side by 12. All right, now, just like in the previous problem, I introduced parentheses or brackets here, so now I've got to get rid of those brackets. And so now you're going to use the distributive property again, just as in number 1. So I get 12 times that first fraction, which is 3x minus 4 divided by 2. Subtract 12 times that second fraction, so like this, 12 times, and then x plus 4 divided by 6 equal, and then I'm just going to go ahead and rewrite this over. 5x divided by 4 times 12. All right, so notice every fraction that you saw here is being multiplied by 12. You see that here. 12 times that first fraction, subtract 12 times that second fraction equals the right-hand side times that times 12. Okay, so now we're going to reduce. Remember, the whole point of multiplying by the least common denominator is to get all of these denominators to be factors of 1. And now I can, because look, 2 divided by that LCD, 2 divided into the LCD rather, is 6. 6 divided into the LCD is 2. 4 divided into the LCD is 3. Now, at this point, you got to be careful because some students are getting confused here. They're going to say 6 times, and they're going to say 6 times 3x is 18x, which it is, but they're going to forget about the fact that every term that's inside that, that's in this numerator has to be multiplied by 6. So what I would do at this point is I would enclose the numerator, which has more than one term, inside parentheses. I'm not going to do that here because that's a monomial, so I'm going to leave that alone. So now when I rewrite it, I get 6 times 3x minus 4 minus 2 times x plus 4 equal 5x times 3. And let's go ahead and do that now. Remember, multiplication is commutative. All this is multiplication. 5 times x times 3. Multiplication is commutative. The order in which you multiply does not matter. 5 times 3 is 15. 15 times x is 15x. So now I still have parentheses. I still have grouping symbols. So I'm going to use a distributive property again. So I'm going to multiply every term you see here by 6 and multiply every term inside that parentheses by negative 2. So 6 times 3x is 18x. 6 times a negative 4 is going to be a negative 24. A negative 2 times x is a negative 2x. A negative 2 times 4 is a negative 8 equal 15x. Now, so notice I no longer have parentheses, so I'm going to combine my like terms though. So 18x and a negative 2x is 16x. Combining your constants, a negative 24 and a negative 8, use your calculator if you have to, a negative 24 and a negative 8 is going to be a negative 32, equal 15x. And now what I'm going to do is at this point, now remember, once you get to that point, you want to bring all the variables one side, all constants to the other. It does not matter which side you bring them on. But I want you to notice that on this side, on the right side, there are no constants. So I can skip a few steps, or maybe one step, by just bringing the variables to the right-hand side. All right, so let's go ahead and see what that looks like. So when I do that, I'm going to get minus 16x. I have to subtract 16x. I can't add 16x because that's not going to help. Mathematically, it's still correct, but it's not going to help because 16x plus 16x is 32x. You want that to be a 0, so you got to subtract 16 minus 16, 0. So 16x minus 16x is 0. But what I do to the left side, to one side of the equation, I have to do to the other side of the equation. And so now 0 subtract negative 32 is a negative 32 equal 15x subtract 16x is a negative x. All right, now remember, you're trying to get x equal, right? Not negative x. See, that's a negative x. You're trying to get x by itself. So be careful. Don't say the solution is a negative 32. It is not. So what you may want to do is think about it like this. So I have negative 32 equal, remember, a negative x. That coefficient is understood to be a negative 1. So if you need to, write it like this. And now we're going to divide both sides by that negative 1. So since I'm multiplying x by negative 1, the opposite of multiplication is division. And so now negative 1 divided by negative 1 is 1. 1 times x is x, so notice I have x now. Negative 32 divided by negative 1, so remember, negative divided by negative is a positive, and you want to simplify whenever you can. So negative 32 divided by negative 1 is a positive 32. And so there's your solution. All right, so that was number 12. Now before I go on, I just want to show you this. So let's say right here, just to give you an idea, so right here, let me go ahead and do that here. So let's suppose that at this point, remember we had this right here, and remember the most efficient way, since this side did not have any constants, was to bring the variables to the right-hand side. But someone else could have done this. So let me go ahead and just show you. So we have 16x minus 32 equal 15x. All right, so that's this step right here. What someone could have done was this. They're going to say, well, I'm going to bring the variables to the right-hand side, constants to the other. And that's fine. You can do that. But let me show you what's going to happen. And that's perfectly okay. So you're going to, first of all, you have to subtract 15x from both sides, just like this. All right? And then you're going to combine like terms. So notice I line my like terms. 16x minus 15x is just x. Subtract 32 equal, now remember, be careful because you do have something, you got to have something on this side. So 15x minus 15x is 0, right? So 0 goes here. And now you just add 32 to both sides. And so combining like terms, a negative 32 and a positive 32 is 0. So you get x equal 0 plus 32 is 32. All right, so either one of those is fine, either one of those steps, okay? And the reason why I did it this way is because sometimes when students do it this way, they forget to put something here. And they'll eventually say this. So when they forget to put something here, they'll say incorrectly, they'll say x equal negative 32, and that's incorrect. All right, so be careful. And notice, remember the direction says show your work. So don't skip any steps. I've got to follow how you're going from one step to another. I've got to follow your thinking. So since you can't speak it in words to me, you're going to write out what you're thinking. All right, so these are the steps. All right, so that is it. So that is the key to worksheet, equations worksheet 6.